In this video, we will demo the OpenAPI integration of the Dashjoin low-code development platform. Now, if you're not familiar with OpenAPI, we have the website right here. It's a standard specification to define the structure of REST APIs. Now, we use this standard and also JSON schema extensively in the Dashjoin platform. And in this video, we will really show three different use cases. So use case number one is, given an existing OpenAPI specification, we want to generate or implement this API using the platform. So in this case, the low-code platform is used to develop REST backends, and the focus is not at all actually on the UI capabilities. So this is called an API-centric or a specification-centric approach, where you first start with the API specification and then second do the code. The second use case is quite similar, but we will actually use the Dashjoin backend and specifically its capabilities to discover database tables and describe them in JSON schema to actually contribute to an existing OpenAPI specification. So this can be quite useful because chances are in your specification you will find components that you also find in your database. So consider classical CRUD operations on tables, which obviously correlate to the structure of tables. And that can be quite cumbersome, and it's nice to automate this. So this is use case number two. And the third use case is a code-centric approach where you simply say, I have an existing Dashjoin app and I would like to generate an OpenAPI specification for that so customers and clients can call my API more easily. Now let's have a look at the setup. In the first window, we see our Dashjoin platform with a Postgres database. Please have a look at some of the other videos on our channel for instructions on how to use the cloud instance or install it locally and how to configure your existing databases. Secondly, we have a Swagger Hub repository of different OpenAPI specifications. So Swagger Hub is done by SmartBear. That's the company behind the open source Swagger UI, which we'll see in the next windows. And it's a central repository that provides a nice editor and management capabilities for documentation and hosting of your APIs. So we have three API specs for the three use cases defined earlier. Then we have the next window, which is the platform OpenAPI. So these are some of the functions that are available with every Dashjoin instance. We will use some of the calls here to invoke some of the functionality for generating stubs and some of these, let's say, API development tasks. And we have, using the same backend, but using a different OpenAPI spec. This is the app API, so the API of the app you're currently developing. And of course, right now it's empty because we haven't really started yet. Okay, so let's get started. Use case number one, we will take this pet store. That's the standard example that you find with these Swagger Hub definitions. So this is the normal pet store example with a few modifications. So first of all, we shortened it a little bit in order to, just for time's sake, and reduced it to the posting, so creating a new pet and getting a pet by its ID. We also configured the system to use this REST endpoint. That's sort of the common Dashjoin application endpoint to make sure that we hit the right backend. And we also, at the bottom of the page, configured basic authentication in order to match our authentication that we have on our backend. The rest is really unchanged, and there are no modifications whatsoever. Okay, so what we do is we can copy this URL, head over to Dashjoin, go to the configuration page, system configuration, go to the OpenAPI specification and say the URL is equal to this value. Now, important here, you have to add /swagger.yaml And in the beginning, you need to change from app to API. So this basically instructs, or this downloads the raw YAML rather than the web page that we had open earlier. So we update and head over to the app API Swagger Hub, do explore again, and now this shows up much the same way as it does in Swagger Hub. The next step is to create the stubs for these two HTTP operations. So that we can do from the platform API. We can search for stub, and we find this here, so we can try it out. We first need to authenticate we'll use basic authentication here, authorize, and we can just create the stubs. That operation is successful, and we can go in here and we can see that the add pet and get pet by ID functions were added. So this platform has basically taken the operation ID from the OpenAPI spec and generated some dummy, simply an echo, which is basically just return what you have obtained. So now we can actually try out these. So now we have created these functions and we can try them out. So for instance, here we can go in, and again, here we also need to authorize on that endpoint. It's actually the same endpoint, but just the window needs to be authorized, and we can say try it out, and we can say pet ID is 123, and we can just run this code because the right endpoint is hit because we've selected it up here, and here you can see the result. And here you can see how this works. So basically the platform has sort of a generic API interceptor, and it picks up all kinds of inputs. So first of all, there's basically 5 inputs. There's the body. In this case, it's null because we're just getting a pet by ID. And then there's different parameters. There's basically 4 kinds. There's cookies, headers, query parameters, and path parameters. In this case, it's a path parameter called pet ID, which we set to 123. And so this object is being transferred to the JSON-ATA function, which we always use in the Dashjoin platform. Echo just sort of returns the result back. And of course, with the other one, it works exactly the same way. Okay, so now in order to actually implement the functionality, we need to create a pet table in our database. And we can do that again, driven by the API spec. So you can create it on the database directly, but this is sort of a shortcut. And we can say, we just look for the create table function, and we'll call it. So try it out. So our database is called Postgres. So here it's important that you have a database, so either a SQL database or a non-SQL database that supports structured types, arrays, and so on, if these show up in the JSON schema OpenAPI specification. If it's just plain characters and numbers, you can use really any kind of database. But here we have some nested structures in the pet schema. That's why we use Postgres. And in the request body, we say, please create the pet table for me. So let's check that again. This is basically the schema of the pet. So we have an ID, which is then interpreted as the primary key. We have this nested structure category, tags, and so we have some arrays in there. And so let's create this table. We'll execute this, and now we just have to reload over here, and so we have this request table, which we'll use later, but here's our pet table, which is empty right now, but it has exactly the same structure. So this was just generated from the OpenAPI spec. Okay, so finally we need to implement the functions and change them from this default to the actual code. So here, instead of echo, we will use, so we get the structure that contains the ID. So we'll use the read function. The read function takes the database parameters, so that would be Postgres in our case. The table is obviously the pet table, and the primary key we need to read is given in parameters dot pet ID. So that's it. we'll just hit update and test it out. So, well, actually, first we should actually create a pet so we can look one up also. So get the order straight here. So in add pet, we basically do the same thing. So we can actually keep the echo in. So the API should return the pet that you added. So that would be in the body part of the object that's used to call here, and we will say create, and the create function also has the same parameters, so Postgres, comma, pets, and we'll just actually put the entire body in, because that is that's sort of where the payload is, the actual JSON structure, and that can be directly written to the database. Okay, that's it. So we'll say update this guy here and go over to test it. So let's head on here. So again, try it out. The JSON schema specification already contains an example object. So this is what the pet object looks like. We just reuse it here. We'll say execute. We can see that this body part was returned. We can also have a look over here, and we'll see that this is now actually in the database. And now we will also test the get pet by ID. So the pet ID was 0, and we will run it here, and also here we get the pet back. So basically with two one-line functions, we implemented this OpenAPI spec. Of course, there can be more difficult cases where you have to have a little bit more complex JSON code, but in our experience, most of the APIs can be leveraging the powerful functionality of the Dashjoin platform with queries and the CRUD support for multiple databases. It's usually a couple lines of JSON that's required. All right, over to the second use case. In the second use case, we work in an API-centric way, but we would like to make our life easier by selectively publishing certain schemata that we have in our local IT systems and databases to the OpenAPI spec. Just to avoid redundancy, avoid redundant work, think about schema changes and being able to publish them to our spec automatically. And that's what we're going to do. So first of all, in our OpenAPI spec, or in the definition here, you can either provide a file-based URL that we can write to that file directly. In this case, we will actually use the Swagger Hub API. And so we need to copy the API key in here, copy, and we'll put it in here as API key, paste this in here, and update. Okay. Now we go back over to our Swagger Hub and look at the contribute specification. So this is empty for now. So just imagine there being a couple of paths deployed, but there's one important point here. So there's a -x Dashjoin part with a -x schemas. And we specify that in the Dashjoin system, in the Postgres database, there is a pet table which we would like to expose in here. And so first of all, we actually need to go back to the specification here and change this from pet store to contribute and update that again. And now we can go back over to the app and do another explore. And now you'll see that there's no operations defined, but we do have this pet JSON schema object here, which we can use in our in this example also. So we're just reusing the same table, but you get the point that we publish a local table to Swagger Hub. Well, we actually haven't published it yet because it's just auto-generated in here, but it doesn't show up on Swagger Hub yet. So we need to save it, and that you can do in the system API and just search for save API, and we'll try it out. So we'll just run it here, and this actually publishes whatever was generated. So the Dashjoin backend actually takes the existing OpenAPI spec, merges the information that's provided in the minus Dashjoin category, and now actually wrote it back. So if we do an F5 in here, we'll see that the pet schema shows up. So the system is complaining it was declared but never used, but now we can actually go ahead and write some APIs that uses this JSON schema. So please note that there's also this -x generated in here. This basically allows us to, so this will actually overwrite. So if I'm making a schema change, for instance, and I'm creating a new column, the -x generated actually indicates to the Dashjoin backend that whatever is published here can be overwritten and replaced with a potential change. So this allows you also to handle lifecycle events and publish these specs to specific versions of your API and then use them in there. Okay, this brings us to our final use case. In this case, we actually work in a code-centric way. So let's just assume, and we'll have let's just create a small sample function. So let's just make a quick add function, and we'll just say, we'll pass an object with x and y, and we'll just return x plus y. Okay, now consider the case that we want to publish an OpenAPI spec for this add function, or possibly other queries or things that we have developed in the platform, and we would like a clean OpenAPI spec so customers can use it easily. So in this case, we'll actually use, again, go back here and just have this add example. And this is just a mere placeholder. So we define the authentication scheme, we define the backend, which is just the slash API in this case, and some definition, but otherwise it's an empty OpenAPI spec. And we'll basically attach that to our system. So again, we go back into the system configuration and we'll switch to add in this case, and go up here and do an explore again. And now you can see that, oh, actually forgot an important point here. So just like we published the, in the contribute part, we published, or we defined a certain table to be exposed. In this case, we defined the add function to be exposed, okay? And just the same way, what happens is that this add path is added automatically, and we can, again, try it out. And very simple, say 1 + 2. And run it, and of course the result is, well, forgot to log in. Okay, and the result is 3. So very simple final case, but in this case we don't want to publish it. It's, again, we work in a code-centric way, and we just have you know, a nice Swagger definition for custom functionality that we you know, exposed either using SQL queries, using JSON functions, or we can also publish tables that we have. All right, this concludes the 3 use cases and our OpenAPI integration. So please, you know, try it out. Head over to our site on GitHub, join our Slack channel, provide some feedback, and let us know what you think. Thank you very much.